Guys, welcome to my channel Education and Masti. So today we are going to start with chemistry's new chapter, that is chemical reactions, and the topics which we are going to study today are physical changes, chemical reactions, and classification of chemical reactions. So let's first start and deal with physical changes. So what is this physical changes? So the changes in which no new substances are formed are called physical changes. Okay, so it's a type of reaction in which no new substance is formed. Okay, so let's take an example for better understanding. Like suppose you're taking water in a ice cube tray. Okay, you're taking water in ice cube tray, and when you freeze it, what you get? You don't get any new substance. You get water only in the solid form. And again, when you melt it at room temperature, again you get back water only. So did you got any new substance? No. So this is only called physical changes. And dissolving sugar or salt in water, or sublimation of camphor and breaking of chalk into pieces, these are all examples of physical changes which we experience in our daily life. So now we will know the characteristics of what? We will know the characteristics of physical changes. So what are the characteristics of physical changes? So the number one is there is no change in the composition of the substance due to physical change. Means no compositional changes being present. And second one is this change is a temporary change. Means it is not a permanent change. It is a temporary change which will be lasting for few time only. Then physical changes can be reversible. So physical changes can be reversible. So what is the meaning of reversible? Means like when you are melting ice, again you can freeze it back. So that is what reversible changes. Okay. So and then number 4 is that there may be small change in size, shape, physical state, etc. Yes, this will of course be changed sometimes. If something is happening temporarily, something should be happen. So small changes there, like size increases or decreases, shape is little bit odd or something similar, or physical state changes, like sometimes from liquid to solid or from solid to liquid or gas to liquid, it happens. Then the last one is that amount of energy involved in physical change is very small. In this, energy is not involved. Energy is not involved. Very small amount of energy is involved. Okay. So I think it is clear for you what are the characteristics of the physical changes. So now let's move on to the next topic, that is chemical changes. Start with this chemical changes. So what is this chemical changes? The changes in which new substance are formed are called chemical changes. Okay, so this is a type of reaction in which new substance are being formed. Unlike physical changes, what we read in physical changes, that there is no new substance formation is present, but in this chemical changes the formation of new substance is there. So let's take some example. What are the examples of chemical changes? Like rusting of iron. Do you know what is this rusting of iron? Actually, what happens when iron is exposed to this oxygen, brown rust develops. You can also see in your iron pipes or in your copy stapler, sometimes it is there. It also rust is there on at that also. So this is rusting of iron. Then more example are conversion of milk to curd, because curd you cannot change back to milk, and ripening of fruits. So that is also one of the example of this chemical changes. So in this, new substance are formed. Now we will know about the characteristics of what? Chemical changes. We will know about the characteristics of chemical changes. So let's start with the characteristics of chemical changes. So the first characteristic is that there is a change in the composition of substance undergoing the chemical changes, which means that this composition changes is present in this. Okay. Then second is it is a permanent change and cannot be reversed. So it is the permanent change. It is not a reversible change like physical changes. So this is a permanent change and it is irreversible. Okay. Then properties of new substance are different from the original substance. So what we understood here, that the properties are being changed. Like before the ripening of fruits, its properties are something different. But after that ripening, its properties are being changed. So thus we can conclude that during this chemical changes, properties of new substances are having different properties, like properties are being changed of that substance. Then we will know that large amount of heat and light energy are absorbed or given out in this type of changes. Okay, means there is a large amount of heat and energy released or absorbed. Okay, large amount of heat and what? Light energy. Okay, heat and light energy are being absorbed or they are being spread. So these were the characteristics of chemical changes. I hope you understood this one. Now let's move on to the third topic, that is chemical reactions. Now let's begin with chemical reaction. So what is this chemical reaction? Do you know? So let me tell you. So the changes in which new substances are formed, they are called chemical changes, and the process which involves chemical changes is called chemical reaction. So thus we can understand that chemical changes first occurs, like the changes, as I told you, the changes in which new substances are formed. And when any chemical change is being involved in this formation of new substance, then that is called chemical reaction. Now let me tell you first one thing. So what is this? Can you tell me what is this? This is one equation, and in a chemical equation there are two things. Okay, there are two things. One is this. This is called what? Do you know this is called what? Yes, this is called reactant side. Okay, this is called reactant side and this is called the product side. Okay, so when we are doing any of the reaction, when two substances are combined, so the substance which is formed, that is called new substance, and thus we can conclude that they are called the chemical changes. Because of chemical changes, new substances form. So that is what chemical reactions are. Reaction in which new substances are formed which involves chemical changes is called chemical reaction. So this one is reactant, which reacts to form the products, which is the new substance. So now let's start. Let me tell you one thing about this chemical reaction is that a chemical reaction involves rearrangement of atoms with the number of atoms remaining same before after the reaction. As you know the law of mass which we have read. So the law of atomic mass, what we have read is that C plus O2, what it is given here actually you need to understand. Okay, like the total number of atoms on the reactant side should be same on the product side also, to follow this law of this mass. Okay, to follow the law of this atomic mass, what it says that the number of atoms on the reactant as well as the product side should be equal. So this should happen, otherwise we are not following the law of mass, because it says that atom can neither be created nor destroyed. So if the atoms are not equal, then we can say that atoms have been created or destroyed. So this is what the chemical bond in reactants are broken and new bond is formed in the products. So this was about your chemical reaction. Now let's move on to the classification of chemical reactions. So now let's start with the classification of chemical reaction. So let's see first the classification. So the chemical reactions are broadly classified on the basis of two things, that is physical states of substances taking part in the reaction and direction in which the reaction proceeds. So these two things we are going to read first. So first you will know about physical states of substances taking part in the reaction. So based on this physical states of reactants and products, as you know in chemical equation two things are present, products and reactants. So on base of this physical state of the substance that takes part in the chemical reaction, these things are of two types, which I have written this based on these things. That is homogeneous reaction and heterogeneous reaction. Now what do we mean by homogeneous reaction? So in a chemical reaction, if all the reactants and products are in the same physical state, then the reaction is called homogeneous reaction. You might have heard about homogeneous mixture which mixes everything in it, mixes. A mixture which mixes everything in it, means everything dissolves in it. That is homogeneous mixture. That is related to homogeneous reaction here. In this, reactants and products, if they are in physical state, then that is called an homogeneous reaction. Means the change is not chemical. The change is physical. Means it will get reversed. That is known as homogeneous reaction. So let me give you first also about the heterogeneous reaction. What is this? Before that, let me give you an example of homogeneous reaction. So one example of homogeneous reaction is like when hydrogen gas reacts with chlorine gas, it forms hydrogen chloride gas as the product. Here you can see H2 plus Cl2 gives 2HCl. Here you can see that this both are gas and this one is also gas only, HCl. So what do we mean by homogeneous reaction here? Means both things are in the same state. They are in the same physical state. So this is known as homogeneous reaction when both the reactants and products are in the same physical state. So this is our homogeneous reaction. Okay. Now we will know about, secondly we will know about what is this heterogeneous reaction. Okay, what is heterogeneous reaction? So the reaction in which the reactants and products are in different physical state, then the reaction is called heterogeneous reaction. So like if they are in different state, like product is in solid state and the reactant is in liquid state, that is known as heterogeneous reaction. So most of the reactions are heterogeneous reaction. What? Most of the reactions which we are studying are in heterogeneous reactions. Not homogeneous but heterogeneous reaction. Okay. So let's go for an example for this also. Let's take an example. So when carbon burns with oxygen, it forms carbon dioxide. What we observe here, that carbon plus oxygen means O2 gives us what? It gives us CO2, which is carbon dioxide. So when we see the composition, carbon is solid, yes, and oxygen is gas, and the formation is of gas. So here we can see the carbon is solid, but the product is gas, not solid but gas. So that is one of the heterogeneous mixture. And one more let me tell you one more heterogeneous mixture with hydrogen and oxygen. When H2, which is a gas, plus O2, when it reacts, you know now it forms water. So definitely it will form water, H2O. Okay, let's balance it out first. Without balancing it will be wrong. So here you can see what? This H2 and O2, these are gas. But the composition, the product which has been formed is what? Liquid. So therefore we can understand that most of the reactions are heterogeneous reaction. Okay, so what is heterogeneous reaction? When the reactant is having different state and the product is having different state. And homogeneous means Both reactant and product are having same state. So now we got a clear cut of homogeneous as well as heterogeneous one. Now let's move to the direction in which the reaction proceeds. Okay, let's move on to that. So direction in which reaction proceeds means, what is this actually telling us about? So like the reaction also has some direction where it is proceeding, where it will end. So that is called direction in which the reaction proceeds. So based on the direction in which reaction it takes place, okay, direction in which a reaction takes place, the chemical reactions are classified. Means like every reaction has a direction. So based on that also it is divided into two types. That is reversible reactions and irreversible reactions. So firstly we will know about the reversible reaction. What is this reversible reaction? Let's first know about it. Reversible reaction. Okay. So in some chemical reaction, some amount of reactants react, forming the products. The products formed get converted back to the reactants. So this reaction continues to proceed in both forward and reverse direction. So such reactions are called reversible reactions. So what do we understood by reversible reaction? That this reaction, when it occurs, then again it changes back. Like for example, as I told you example, when in a cup of water, okay, this is a cup of water. Let me draw it in a nice image. This is a cup of water, okay. A cup of water is there, okay. So in this water is there. So when we add some sugar crystals in that and when we dissolve it in that, the water gets dissolved. And we can obtain sugar back by evaporation. We can obtain sugar back by evaporation. So here what it is happening, if we dissolve salt also, then also same thing happens. So we are getting back both water and sugar as our residues. So that is what reversible reaction tells us. Whenever a reaction is reversed, means we can bring it back to its own state, then it is called reversible reaction. And as we see, most of the reactions are denoted by the arrows. Like most of the reaction we see, arrows are denoted, like it is denoted as like this. Okay, arrows are denoted like this in chemical reaction. But in a reversible reaction, what happens? In a reversible reaction, the arrows are something like this. Something like this the arrows are, okay. Let me draw a clear cut image of that arrows. You can see this is something like this. This type of arrow is drawn in reversible reaction, okay. In reversible reaction, this type of arrow is drawn. This indicates that the reaction can be reversed. Now let's take some of the example of the reversible reaction. Okay, let's take some of the example of reversible reaction. So our first example is number 1. When nitrogen reacts with hydrogen, it forms ammonia. We know that. And the reaction is reversible. How we can reverse it? Let's see. N2 is given plus H2 is given. And here you see arrow. By seeing this arrow, you should understand that this is a reversible reaction. And thus the product we are forming is our ammonia. So this arrow indicates that this action can be reversed. And let me balance this first, 2 and 2. Here you can see balancing also we will see sometimes. See, N2 is given, H2 is given, and H3 it is given. So we have to balance here. Now 4 atoms of N, nitrogen it has become. So let's put here 2 first. Okay, let's put here 2, then let's put here 3. So 2 3 is 6, 2 2 is 4, 3 2 is 6. Here we have done this one. Now let's see. This one is also gas and this one is also gas. This is an example of homogeneous reaction, but we have to find here that this one is a reversible reaction as the arrow indicates. We can again reverse the situation. We can again change ammonia back to nitrogen and hydrogen. So clear? Now let's move on to the irreversible reaction. What is this irreversible reaction? Let me tell you. First, let's write it down. Irreversible reaction. Okay. Irreversible reaction. So, in some chemical reactions, if all the reactants are completely converted into their products, the reaction is called irreversible reaction. The other name for irreversible reaction is chemical changes, and the other name for reversible reaction is physical change. As you have studied in the beginning of this chapter, that the changes which can be reversed are called physical as well as reversible change, and the changes which cannot be reversed or are irreversible, they are called this chemical changes or irreversible changes. So the changes which cannot be reversed and which has been completely converted to its products, then this is called irreversible reaction. So let's take some example of irreversible reaction. So let's take the example. Okay. So C plus O2 gives us CO2. You cannot convert carbon dioxide back into carbon and oxygen, as the arrow here which is indicating that this is an irreversible reaction. So the reaction which cannot be reversed, they are called irreversible reaction, and their arrow is this. And as I told you, reversible reaction, as the arrow something like this. Okay, they are having the arrow of this. Now let's take one more example. So Mg, which is magnesium, plus O2 oxygen, gives us MgO. Here let's see, first balance it. 2, 2. So this is irreversible reaction. Understood? Now we can see that here this arrow represents the irreversible reaction. So you know this one is reactant and this one is product. So with this we complete this video. In the next video I will tell you about the characteristics of chemical reactions. So here what we studied, let's take a revision. We studied about physical changes, we studied about chemical changes, we studied about chemical reaction and classification of chemical reaction. I hope you like my video and also you have understood this. If you have any doubt, you can ask me in the comments, and please subscribe my channel. Also hit the like button and share with all your friends. Thank you for watching this video.